So good afternoon, everyone, and good morning to Hendrik and your friends from Europe. Very early day. I think it's 8 a.m. right over there. Yeah. Thank you for joining us. We are here live at BeyondX, and I hope everybody is keeping well and safe, sitting comfortably at their home. We have a very interesting talk today. We have with us esteemed speakers from Cobot and Autodesk. I'm TY. I'm a director in architecture studio in Singapore from ONG&ONG. And I have my companion Daniels.
Yes, I'm Daniel Chandra here. I'm the Director of Digital Technology at ONG&ONG here in Singapore.
And just a quick intro, BeyondX is our annual design festival showcasing fresh technologies and speakers from all over the world. This year round is all over the world. Previously, we have our local speakers to inspire creativity and innovation, to share their knowledge and the current developments in the world. So today's session is Fit to Print, Building Digital Fabrication. And our first speaker is Hendrik Luke Nelson. I hope I got your name correctly. He's the founder of Cobot in Denmark. And Cobot stands for construction of building on demand. Yeah. Well, Cobot is actually a leading company with 3D construction technology and 3D printing press, and is considered one of the leading experts in this field. Today, Hendrik will share with us current developments, especially in Europe, with the 3D construction printing industry. So, and Daniels, maybe you can have the pleasure to introduce you.
Yeah, so we also have our second speaker, which is Vijay Ramadas. He's a senior research engineer at Autodesk Singapore. Vijay researches and develops solutions on flexible manufacturing and the applications of robotics, automations, and hybrid manufacturing techniques. He generates ideas and processes to enhance advanced systems for our industry. Yeah, so that's about Vijay. Okay, so just a little bit of housekeeping here. So maybe Jianong, use the next slides. Yeah, just a quick reminder for all the Zoom attendees, don't worry, your mic and cameras are disabled. If you wish to make comments, click on the chat at the bottom left. Tell us where you're from and how you find the topic. If you want to ask questions, click on Q&A at the bottom right. Tell us which speaker you want to address your question to. If you guys are turning in via Facebook, please post your queries in the comment sections and we will try to get back to you. Audience questions will be asked at the end of the session. So that is after the first speaker did a presentation. Okay, so now let's start with the first speaker, Hendrik. So the screen is yours. You can share your screen now.
So, good afternoon. My name is Henrik Lund Nielsen. I am the general manager and founder of Cobot in Europe. And as Ty was saying, Cobot stands for Construction Building on Demand. And I'm labeling my presentation from research of state-of-the-art to becoming state-of-the-art, because our start was in fact that we only did research, and right now, in all modesty, we do believe that we ourselves now have become state-of-the-art within 3D construction printing. So if we look at our development, as I said, we started with 3 years research under a government grant, where together with NCC, the largest construction company, we were touring the whole world. So this was a global investigation caused by the fact that the Danish government was afraid of that we were falling behind as a nation within construction printing. Denmark is a little bit a funny nation. If we are not number 1, 2, or 3 in some industry, we get nervous. So the government was getting nervous and wanted to promote this technology, and so they tasked us together with this big construction company to tour the world, investigate all these projects, and bring home the best bring home state-of-the-art, to say. So that took place over 3 years. During that process, we also did 2 test printers. We tested 20 different recipes or materials for the printers, and we visited 38 different projects. I don't think anybody in the world has ever visited that many 3D construction printing projects, and I personally visited 35 of them. So I think, in all modesty, I can say I have the broadest knowledge of what goes on in the world in this industry. As a consequence, we had 2 conferences organized, and at that time they were the biggest, with 200 attendees just to hear about construction printing. And we also issued the only report that has that's ever been written about construction printing. It's 108 pages. We have been asked for many, many copies, and sorry, it's only available in Danish, and the Danish government will not allow us to translate it, because this was information for the Danish construction sector, not for the world construction sector, so to say. Anyway, the result of this research was, in fact, that we were actually very disappointed. It turned out that there had been so much misleading PR. And in general, we are saying, when it comes to construction printing, 95 to 98% of all the PR that has ever been issued is unfortunately not true. It is false, it's misleading, it doesn't really give the true picture. The best example I can give is there was a company in China called Qingdao, located in Qingdao, and they claimed to have the biggest construction printer in the world at that time, 12 by 12 by 12 meters. So we thought that's hugely interesting, such a huge printer at that time. So we went to visit. It turned out that the printer was just a metal structure. It didn't have a printhead, and they never put concrete to the printhead that didn't exist, and they never printed anything. But they had the framework of a printer. And I think this story really shows a lot about how the industry was, and unfortunately still is a little bit. So you've also heard, probably most of you, these stories about a 3D printed house in one day, done by, for instance, APS Core, or done by Icon. Again, it's not true. They were not done. They were done in 4 months, and so on. So on the one hand, we were extremely disappointed that the actual results were not better than they were. On the other hand, it was also clear from our analysis that it was the lack of 3D printing technology skills and competence that had caused this situation, because most of these companies and organizations were not 3D printing experts. We, on the other hand, came as being 3D printing experts. We had another company solely focused on 3D printing for 6 years. And so we said to ourselves, wow, there's lots of potential here. And if it was just done the right way, this could really move the construction world. So we took it upon ourselves to do the first proof of concept. So we said we're going to develop the best printer in the world, state of the art. And with this, we're going to print the first building in Europe, which we called the BOT, building on demand. And typically for us, we did it under full surveillance of the press and of people. So I'll show you a little video of what actually happened. You can see lots of press, even the mayor available, 150 spectators, and we were printing at the same time. Obviously, this was a first of a kind project, and we made many, many mistakes. Here's the finished building as it's standing today. We made many, many mistakes. It took 2 months, but we still completed it, and people were still very, very impressed. The journalists were saying, wow, and we were like, wow, yeah, okay. But, you know, what can you expect? It's the same time as when you learn to ride a bike for the first time. You fell down all the time. You know, the second time you fell down a little bit less. The third time you might have stopped falling all the time. And by the 5th time, you were actually riding the bike more than falling on the bike. And by the 10th times, you were actually riding pretty fast, and faster than you could run. And this is the same thing. Nobody masters a technology just because they do it once. Anyway, this led to extreme demand for our printer. People wanted to buy that printer. They wanted us to do projects. But we said, hang on, that printer could be done even better. You know, we found out during the first project that there were so many improvements that could be made. So we decided, no, we will hold back. We will spend even more time on developing a new printer, and we did that, which is called Bot 2. So it's the only second generation printer that is out there. So we spent about 10 months developing that. We spent 5 months developing the first printer, and now we spent 10 months or almost a year. And that because of that, because that was really, really state of the art, this is like a Mercedes 500 compared to a cheap Chinese car that the other guys are having. Then Perry, the next thing that happened was that Perry, which is the biggest manual competitor, selling formworks equipment all over the world. They have 80 subsidiaries and 20,000 employees or something like that. So they are the biggest manual competitor. And they basically said, well, we can't beat these guys, so we better join them. So by October of 2018, they joined as a minority shareholder. And that, of course, was a huge quality stamp on our organization. So by January, we then delivered out the first printer, and we delivered the next by April. And these are, in fact, 2 tenders, the only tenders that has ever been made in Europe. Because in Europe, when public organizations are buying, they have to do a tender. And we won both of them. And those were 2 educational/technical universities. Then by July, we made the biggest printer that has been made so far in the world. It is 27 meters long. It is 12 meters wide and 10 meters tall. And with that, you can build printings or print buildings with a 300 square meter floor plan, as you can see down here on the lower picture, in 3 floors. So you can actually build a 900 square meter building. So forget thinking about this technology only as small buildings and so on. In essence, we can do the building as big as you like. There's some limitations in the height and the width, but we can do them as long as you like. Let's have a look at how that printer looked like. Notice the car down in the left-hand corner. So this is heavy-duty construction equipment. You are looking at hardware weighing 16 ton here. So it's not a flimsy little toy thing. This is a heavy-duty construction machinery. Yeah, that was sold to Saudi Arabia. And then by August, we then won this iconic project by Emaar. Emaar is the Sheikh's real estate company in Dubai. And as you might know, the Sheikh has decided that 25% of all buildings in Dubai in 10 years from now will have to be 3D printed. So it's a hugely interesting market. And we won this project about building this villa, which is quite iconic, as you can see, very special design, very prestigious project. We have actually done it, but they are not making it public yet because of Corona. Then with the help of Perry, we began distributing our printers in Germany, Austria, and Switzerland. And Perry is supporting us with 150 sales guys in that market. Now I have a problem because I can't see what the next slide is saying because you guys are in the way with your, how do I move you guys away over on the right-hand side? Oh, like this, okay. So by September, we then said, hey, you know, we did the first building 2 years ago. It took 2 months. Now we've done a much better printer and we've gained much more experience. Let's do it again. Let's print the same identical copy of the same building and see how fast we are. So we did that, which is crazy also. Nobody has done that before, printing the same building twice. And typically for us also, everything is on camera, everything is on time lapse. So you can see everything we do. You can also see when we fuck up, sorry my language. Because again, you can't expect to be perfect the second time. You can expect to be better, but not perfect. And you can see there's a timer on the bottom, so you can follow how far we are coming up at what time. And again, full documentation is supplied. We had various issues also when we did that. It didn't run perfect, but we came down to 28 hours. So we went from 2 months down to 28 hours. That's like a 30 times improvement in productivity just by doing it the second time. So now what would happen if we did it a third time or fourth time? Because we're not a construction company, we are a robotics company. But you can imagine yourself the productivity increases that happens as you gain more and more experience. So if we had to do it today, we would expect that we could do it in 8 to 10 hours. Then by October, we entered into a long-term cooperation with General Electric and Lafarge. And I don't think, at least General Electric, they don't need further introduction other than to say that they're very, very large within windmills. And Lafarge is the world's biggest cement makers. So these are companies with 200,000 and 100,000 employees. And then our small little company, but we just happen to have the technology that the other guys need in order to make very tall windmills. So this is the idea of that project, that we should make on-site print very tall buildings. And we started printing the first 10-meter windmill tower last year. And we will see a video of that now. Notice what happened when we come up in the height. You don't see any people at all. You just see the printer working. So where are the guys? You know, there are no guys around. Oh, sorry. Right. And of course, this is a long-term cooperation, so we are continuing doing lots of stuff with General Electric and Lafarge. And then this customer, the educational institution in Belgium that we supplied a printer to, they actually used it in November, but they first published it now, to print a 2-story building, the first 2-story building in Europe. Let's see how that looks. This video has been downloaded 350,000 times, a testament to the extreme popularity that the technology has right now. They did one good thing. They left the printer even after they finished the building, so everybody could see that it was done on site. Very nice trick. Then by December, we had a visitor from Japan. And they were talking about a project, and they hadn't talked about that before in our previous discussion. So we said, you seem to have a project. Do you have some drawings? And they said, yeah, we have drawings. So I said, can you send them to us during the meeting, right? So they sent it during the meeting. 3.5 hours after, we were standing in the warehouse and we were looking at the first meter of their building, as you can see on these pictures here. And you can also notice the huge improvement in the smoothness of the wall quality that we have made, right? And that just shows you the extreme fast conversion from digital files to physical product that is possible with this technology. Then we started selling in the US, and we've had the first 2 printers shipped out to the US, to respectively Florida and Texas. Very well chosen. Now when you look at where COVID is hurting the US, it's exactly those 2 states it's worst. So we haven't been able to go there ourselves yet, but the printers are there. And very unusual for a startup, we actually turned profitable already in the 2nd year of our operation in 2019, which is quite an undertaking. Again, to prove more that how much we had improved, we showed up at an exhibition live, and we said, we're going to print a small house every day in Germany. And so we did that. It's a very small house, but it still proves a point. Notice how many visitors are there looking all the time. So there's no fake here. There's no fake video editing. People are seeing live what we're doing. This is the logo of the exhibition that we are printing in the middle. They wanted to have that logo in concrete, so we printed that for them. But more interesting maybe is a more detailed shot, because these time lapse, they don't show that many details, but we can see some details here. Again, you notice when we use the flaps, the walls become very, very straight and smooth. We can't use the flaps on the lowest layers, but we can use them as soon as we come up in the height. This is again very much different than our competitors because this is real life. You can't hide anything. So we were obviously the talk of the show because nobody had done this before, printing 4 houses in 4 days. Then we actually also started selling printers to Africa, which was new to us. And we've also now started selling into precast plants, which is new to us. Normally we have been focused on on-site application, but now we've actually sold into the first precast plant. And in total this year, we are growing 75%, which if you think about Corona and so on, it's not bad. And today our customers are then counting, 4 different groups, you can say, large corporations like we heard, GE, Lafarge, EMA, Perry. These are big companies. The precast plants, as I spoke about, educational institution, and then real estate developers. We have a big amount of real estate developers that wants to move into this technology and sort of shortcut some of the construction companies. Just a few words about our printer. It's modular, so you can build it in any direction that you like with these modules of 2.5 meters. So that means that you can do the size that you want. There are some limitations. It's 10 meters in the height right now and 15 meters in the width. But in the length, you can go as long as you like. So we can just see a few more details about the printer here. I think I still have 3 minutes, right? As you can see, it's extremely fast. The printer goes up to 1 meter per second, which equates to almost 10 tons per hour. And as a comparison, the first building we did had 20 tons of material. So that means if we put it to full speed and we could utilize that, we could print the house in 2 hours. This is showing how easy it is to change nozzles. So if you want to change the width or the height of the print, you just put on another 3D printed nozzle in 2 minutes and you're ready to go. And of course, our printers come with our own software. It comes with cameras so that you can actually see what is going on. When you're up there, 10 meters up there, you can actually see on the screen what is going on with live cameras installed on the printhead. You can also see the parts. It's like I'm saying, this is a Mercedes 500. This is not a toy. It's IP67, so it's safe to operate outside also, even if it rains, etc. That's not a problem. You see the cameras there mounted on the printer so that on the laptop you can follow how the print is going. And it's of course EU certified with the safety mark. So my last slide is just about the advantages that you're getting with this printer, which basically are 12 unique advantages. You can get the size you want. It's safe and EU certified. It has this fantastic speed of 1 meter per second, and you only need 2 operators to operate it. You're free to choose any concrete or mortar material you want to print with. We don't force you to print with any particular material. It has this very, very high quality, as I said, and it has this ability to have flaps and tangential control where you move the print head in the print direction to allow for that you print very smooth walls. You can easily change the width or the height just by changing the nozzle. And you can either feed in material through a pump if you're doing an industrial, or you can feed it in directly at the print head if you're testing something. And it comes with this state-of-the-art software, and it has a probe, a sensor. So even if you have an uneven surface, the printer will compensate for it so that you will still print straight, even if you start on an uneven surface. And by that, I conclude my presentation.
Thank you, Hendrik. Amazing stuff. Well, design of robotic construction printers and automatic processes. I'm really quite excited. I have a few questions in mind, but I think we'll leave the questions.
Please feel free, everybody feel free to ask as many questions as you like. I'm
Yeah.
here all morning if you like.
Yeah, I have some burning questions, but I think we leave the questions at the end of the session. Maybe we hand over to Vijay to start the second presentation. Vijay?
Hi, yep. So let me share my screen. Can you see my screen well?
Yes, we can.
Okay. Hi, yes. Yep. Hi, everyone. My name is Vijay. I'm super excited to share some of our key technologies for, representing here to as like Autodesk research guy, and sharing some key technologies in future making in construction. I'm a part of a research team under CTO's organization and based in Singapore. More than 600 employees in Singapore with 300 more than over 300 research engineer developing various solutions and softwares for our future customers. So in total, we have more than 11,000 employees worldwide and 18 million active users. If you're familiar with Autodesk, we make software tools that helps customers design and make anything from high-rise building to building components to bridges and blockbuster games. 38 years ago, we started with just one product called AutoCAD and start creating software tools to help people with the design challenges every day. We have been innovative since ever. In early 2000s, we introduced 3D modeling and BIM-based design. Today, we are developing tools for cloud-based BIM process, or we called Autodesk Construction Cloud. Our AC customer use these tools to collaborate better and visualize, manage their data from the office to the field. And we are thinking about tomorrow by researching and developing the disruptive technologies and process that will change the landscape of future. So what does it will take to build something better? What is the technology's key role? So in order to adapt the new technologies, we have to think of three things. So if you want to do something, you need something to build first, or you need to have a smart things, or you need to have a process or making, or you need a changing way to work. So I'm going to talk more on the making side. So when I talk about the process of making and how it will be different, we're talking about ideas and practice from another Autodesk support industry like manufacturing to increase the productivity and efficiency in the design and construction process. Industry one using traditional method to design and build the future. So what we have to do is we have to think out of the box. So instead of we'll be relying increasingly on prefabrication, building a factory before we get on the job site to assemble our project. And the key thing is we had to rely on this kind of instruments, and there will be many different variants. So robot will be a broader, more significant role too in this region. So helping construction teams to solve skill labor gap and build faster using these kind of robotic solutions. So this will make more dangerous tasks. This will take our more dangerous tasks to protect the safety of the construction workers. The means of production will also change. The advance of the technology like 3D printing and IoT will help to monitor the track activity on the job site to boost the productivity. So I want to show some of the key technologies here, especially on the manufacturing of and assembly and 3D printing in robotics. When we talk about the process of making, how could it be different? We're talking about using ideas and practice from another Autodesk support. In, the industry, no. A growing population will require construction industry to do more with less waste of adopting robotic automation. Components for constructing should design for automation, autonomous vehicle, additive manufacturing, and other types of robotics and automation are beginning to impact construction site. This is an example, Fast Break Robotics from Australia. They lay real bricks. In order to do that, they have to know the building information, and they have to do a geolocation with the actual CAD model as well as the robot itself. So they use Autodesk Forge platform to create automated applications and process by connecting various different softwares within the Autodesk itself. This is another example. It's a company called Scansa. It's a robotic drilling company used in construction. They use Norway's Lynx robotic drilling machine on this project. So they claim it's a first mobile robotic drilling machine, and it's 8 times faster than the manual worker. The robot is geolocated again and connected with the building information model. The BIM is what the robot, so it can drill the holes for installation of MEP systems with some millimeter accuracy. They use a BIM and BIM 360 and Forge platform to feed the data to the robot to put the laser marker and automate the drilling operations. This is a company in Singapore. It's a woodworking company. They use manufacturing tools and technologies to replace their highly skilled carpenter using a robotic arm to build the resorts around this region. So they use Autodesk Power Mill manufacturing software to generate offline cutting path to run their ABB industrial arm to cut size. So Autodesk helped them to automate the entire robotic programming process to eliminate mistakes and increase the productivity using our support, the company invented new type of reinforced fire retardant sustainable wood, which they branded as One Wood. So you can see all these robotic. We can do tool change to we can change the tools according to the feature of the wood or the shape of the wood. This idea is from, again, a manufacturing industry, and this is done with additive manufacturing. So we call it as 3D printing. So a lot of potential 3D printing to reduce the waste of AEC industry by allowing firms to only produce what they need. Autodesk worked with this firm called X3 to streamline the process of 3D printing with information from building from BIM models. You can see the X-ray is printing a drainage pit. So 3D printing allowed to save the cost and creating a cost of expense to save the expensive framework of the concrete. So by this we can remove, avoid the eliminate the waste of the process as well. We gave our AC side expertise to design the pit. We provide the software solutions as well as the manufacturing solutions to slice it and run through the robotic simulation and print it. This is another idea is demonstrating a 3D printing expansion form. They pour concrete into the expansion form mold to demonstrate the printing capabilities. So this is done in France with a collaborate with the university. We started design from Nozzle itself using our safety simulation analysis tool to design a good nozzle. Then we bring that design into our manufacturing solutions to generate the slice and path. The robot path and speed we controlled in such a way that the form is fully expanded when the next layer is printed on top of it. So we make sure everything is cured or expanded properly before the next level reach. So we also have a digital twin capabilities also. So you can add reinforcement or whatever within the expansion within the mold itself. In this, another idea of sustainable housing habitat in deep space using additive manufacturing for NASA. This was a competition, and we worked with the AI Space Factory on this project. Was an attractive endeavor because the construction technology developed for use on the moon and Mars could provide valuable benefits here in Earth, like low-cost housing solutions using recyclable or locally sourced material. So in this project, we have to work with the material aspects as well, 3D printing technology, and the characterization of the materials. Yeah. And I'm showing this video.
Roger, go for deploy.
The idea of colonizing another world has always been a fantasy of ours. It is in our nature to pioneer new lands, to settle and inhabit even the most unforgiving environments. If NASA's astronauts are to have a long-term presence on the moon or on Mars, they'll need to figure out ways to build habitable structures, something that will protect them from the extreme temperatures, radiation, and micrometeorites. NASA's engineers face a major challenge. Shipping large quantities of cement or other heavy building materials aboard a rocket just isn't practical or cost-effective. Engineers at NASA's Swamp Works are developing a solution: 3D printing habitats on other planets using natural resources found on-site on the planet's surface.
Along the way, we discovered that what they are doing, and then we realized how this could be utilized for the industrial construction, how we can build the sustainable structures.
Using new additive manufacturing technology, combined with the latest advancements in material science, structures can be sustainably built using a combination of local materials and lightweight recycled materials. By mixing small amounts of plastic waste with lunar or Martian regolith, similar to dirt and rock found in desert climates on Earth, a cement-like structure is formed and composited into place with robotic precision.
We are using Fusion 360 for the design, PowerShell for the redesign, and PowerMill for the toolpath generation.
The technology that we're seeing today is incredibly valuable because it's using automation in order to produce that. So that means that I can repeat the process in even the most remote area of this planet.
The materials and techniques being developed on this project have the potential to revolutionize the way we do construction here on Earth, too. Plastic pollution could be recycled to sustainable 3D printed streets, sidewalks, playgrounds, even habitable structures.
This is really the future of making things, is how we reimagine designing for manufacturing. So now we need to rethink how we design and manufacture parts by joining these two skills in one.
We have the opportunity to advance them together in order to reach new frontier, either to impact the life here, but as well the life in the moon, in Mars.
Ignition sequence start. 3, 2.
Yep. With that, yep, that's it. Thank you so much. Let me stop sharing.
All right, thanks, Vijay, for the presentation.
Yeah.
Okay, so so maybe we just start with the questions from the audience.
Let's invite Hendrik back and
Yeah, Hendrik is here. Yeah.
I'm here.
We will just have a well, kind of informal discussion. We have some pressing questions from the audience. Maybe I can just start, right?
Yep.
Well, Alvin Key would like to pose to Hendrik. He said, as seen in your presentation, 3D printing has already been used to create architecture, but always in a very small scale. Do you foresee this technology being feasible to be brought for on-site fabrication, printing of smaller houses, as the printing system and the technology now is modular, right? So if you foresee this in the near future, how do you overcome difficulties such as unpredictable factors like, I would think, weather, seismic calculation and condition caused by the environment? Yeah. This is from Alvin. Yeah.
I don't only foresee it; it's happening. You know, all the printers that we're sending out are now being employed in projects where they will do real houses for real people. So it's really happening. We can always discuss what is big and what is small, but I mean, as I told you, the printer that we sold for Saudi Arabia could print 900 square meter building. If you look at the buildings all around, except for the 5% high risers, you know, most buildings are 1, 2, 3 stories. Our ambition is to go to 5 stories, and then we think it's probably the end of it in terms of on-site. And at least for the majority of cities, if you go to 5 stories, then you've covered something like 85 or 90% of all buildings. Then the second part of the question, how do we account for let's say, conditions that are present at the site? Well, that's not different from any other construction project. Most construction today, globally seen, is actually done as on-site casting of concrete. Yes, there is precast, but precast is only developed really in a few selected countries. So in my country, for instance, we are totally precast freaks because we believe in automation, we believe in industrialization. We don't like, let's say, manual work on site, but just go to Germany. On-site casting is way bigger in Germany, and they have the same belief, but they just, you know, they have the same trust in industrialization, but they just like the fact better that when you do it on site, you don't have all the transport restrictions and constraints. You do not have to reinforce as many parts as you do when you do precast, because when you do precast, all parts have to be reinforced, although it is not necessary for the building. So it's also more wasteful to do precast. So we take the same precautions. The printer, as I said, is safe to operate in rain, so that's not a problem. But you cannot, in essence, cast in rain with the concrete. So you would have to wait for the rain to stop. But that's not different from any other concrete. Any high-rise structures you have in Singapore are made predominantly with the in-situ casting of concrete. They have to take the same precautions. If the weather is really bad, they can't work. So not a big difference, I would say.
Yeah. Okay. Maybe just also to follow up with that, I was just looking through the other many questions, and now that it's possible that you're looking at building taller buildings, higher buildings, and most part of the world today will be, of the world population will be moving to cities. So do you foresee at some point of time, while we see that it's possible to 3D print with different materials, do you foresee that 3D printing would be compatible, say, with steel reinforcement?
Sure.
People higher, taller, and
Sure.
I mean,
Of course, we are already reinforcing the structures that we are building, and we are trying to do that more and more automatic. Here, the printer can also help. For instance, we're working on a project now where the printer is carrying in the reinforcement and placing the reinforcement. But the killer application in terms of how do we automate it or automate it 100% still needs to be found, a general one, because we can put steel fibers in there and that can take care of some of the reinforcement, but the real totally automated general reinforcement solution that can be sort of standard applied in most projects still have to be developed. Again, we're working on it. There are 300 universities or so working on it because everybody knows that we need to think about the integration with the reinforcement. So I'm sure we'll get there. This is similar to how it was with, let's say, mobile phones. Most of you guys are too young to remember that. But when mobile phones came around at the end of the 80s, they were suitcase size. They cost 3,000 euros. And they could hardly call anybody, and definitely they didn't have color screens or anything. And then just 5 years later, we had the first handheld, small, really mobile phones. We called them car phones or similar because they were installed in cars still. And then a couple of years later, we were all running around with them in our back pocket. And this is where you should see the industry. We are maybe not where the bulky mobile phones were. Initially, but we're somewhere in between that and the handheld device that we're all running around with now. And it will only take a few years, we'll be there. So I think this is going to change the construction market a lot. Whether it will take 20, 30, or 40% of the market, nobody has a clue, because it's very, very difficult to predict the future, of course. But we are constantly surprised about the interest. I mean, as I told you, we sold 2 printers to Africa. Had you asked me last year, I would say Africa is of no interest to us. And you know, this is not like South Africa and developed African countries. It's actually among the least developed African countries that we sold printers to.
Yeah, so Fiji, based on your Autodesk research, right? So
Yep.
what do you think about this mixing materials and, how these things actually progresses as well moving forward?
Yeah, so it's definitely looking forward on the like a sustainable housing. Like for example, if you have a material on your site, it's how we could make use of that. This kind of for example, in Singapore, we use concrete a lot. Maybe in some other country, they use some different kind of material. So the material we have to, we really need to work on it. I mean, like we have a team working on that as well. Yeah.
That's very easy, Vijay. You just change the regulations all over the world. No, I'm serious, because concrete is the most used material everywhere, and part of the reason is that the regulations are promoting standard concrete. So, for instance, when we put 23% recycled tiles in the first project that we did, right? Because we like to be green, we're extremely green as a country.
Yeah.
And the authorities said, great, we like recycling, but you have a problem. And I said, well, why? I said, well, because we don't have any concretes with recycled materials that are approved. So, that's what you're going to run into.
Yeah. So
that's why we solved it by having columns. We printed columns with our very strong concrete with recycled tiles, non-approved. And then we took a much weaker concrete, poured into the column, put rebar in there. And according to the authorities, that much weaker concrete, that is 40% as strong as ours, was the load-bearing part, because this was according to the regulations.
Yeah.
So it's a serious hurdle, this one, for innovation, the regulations.
Yeah.
The patterns and the norms.
100% into that. What I'm thinking the way, so we no need to build only like a housing structure, so it can be something else. So we could use like a low-cost material in the place where we live. So yeah.
Yeah, and not all. I mean, if you look at brick housing, which has been around for hundreds of years, you go to my country, you can find brick houses that are 400 years old and so on. They're not reinforced. So a lot of structures, they don't need reinforcement, which is also, the other argument against precast, because when you do precast, you have to reinforce each element, otherwise you can't transport them.
Yeah. Okay, let's just go back a little bit. In terms of the processes, right? When you say that, okay, this thing can go to your printer, but prior to that, for architects, for example, for structural engineers, how do they actually design this thing? I mean, we know that right now we kind of enforce everybody or make everyone actually go for this thing called building information modeling, right? So from BIM, for example, will this can be translated straight away to the printer, or is there any intermediate processes that needs to be done beforehand?
No, not with gantry printers. With gantry printers, it's actually as easy as you take your Revit file from Autodesk or from AutoCAD. You export a step file, and within 2 minutes you have the print file.
That's it?
So if that's it. If you architects have done your job correctly, but you know what? Most often you haven't. So we pick up on that. When we do this in 3 dimensions, you run into trouble, and that's because the architects are still mostly used to plan and make drawings in 2D and then lift them up in 3D. But when we turn them into a 3D model that we can look at from all sides, etc., we pick up on that. Hey, you did a mistake here, and then typically we spend 15 minutes in correcting it, etc. But that's only until the architect knows that what he has to be careful with, etc., etc. If you do your job correctly, our software will automatically it takes 2 minutes, we have the print file. That's different when you have a robotic arm. But when you have gantry systems, so it's not only us, it's everybody that has gantry systems can do that in general.
Okay, that's great.
So it's not so difficult. It's working with your normal tools and AutoCAD, Autodesk tools, right? So just do a Revit file, export it in step, and then you're good to go.
Yeah. So imagine you have some assembly when you're doing a printing. For example, you're assembling your window while you're printing. So in that case, maybe we need to add more element into that. So yeah, other than it's like a straight slicing and generate the G codes. Yeah.
Sure. I mean, as soon as the printer starts to have more functionality, I mean, why can't it do painting also, for instance?
Yeah.
Then we have to revisit the software part and so on. But we take it upon us to, if we add more functionality to the printer, then we will also basically have to do the software part.
Well, I guess this one also related to one of the questions here from the audience. Say, how about like printing organic shape, that kind of that kind of weird ones, or that kind of it's not like a straight boxy kind of thing, right?
So if you looked at the bot building,
yeah.
If you looked at the bot building, the bot building does not have a straight wall, and that was deliberate, completely deliberate. We even did waves on the walls, because we are in the harbor, and good architecture, as you know, should reflect your surrounding and should tell you something about where you are. So we had waves going around the walls. We had lots of fun when we did that, but that was only until the roofing guy came, because at that point we were not doing the roofing ourselves. We had a roofing guy, and he came in and he looked at these walls that had to connect up to the roof, and he looked and he said, this is going to cost you 5 times the normal price. So with that, I'm saying, don't go bananas. We don't care. From the printing side, we don't care at all. We can do whatever you like, but don't go bananas, because there will be some other guy who will kill you with his prices because you've done something crazy. So.
All right.
Adding into that, we have manufacturing solutions which show the user in upfront before you print something overhang, like for example, like a banana shape. So what we are trying, we're trying to bring that into concrete. So that's what some research is going on there. That's it. Yeah.
That's another interesting point, this thing about the overhang. Overhang means that you print where suddenly some part of the structure is not leaning directly on what is underneath.
Yeah.
And we've been asked many times, and it's like that with a lot of questions. We can't give a specific answer. There's not one truth here. Yep. And we've been asked many times, so we said we think we can do 20%. And then we had a demanding customer who said, but why can't you do more? We said, well, because there is a limit to, you can't print in free air, right? So we said, well, okay, we'll test a little bit and do various things, and after our 5 trials, on the 5th trial we printed with 30% overhang. So and that was by changing the layer width compared to the layer height. So by changing these things, we could actually change the angle of overhang that we could do. But it's a reflective again of the fairly unmature state of the industry, that there are a lot of these questions we can't answer because we haven't tried it. There's so many combinations possible, and we simply haven't tried them all. It's impossible. There are millions of combinations.
Yeah.
Okay. So perhaps another one for Vijay here. I know you mentioned about Autodesk Construction Connect or Construction Cloud, right?
Yeah.
So how this entire ecosystem of design plus construction, and now construction now become kind of a robotic interconnected of the whole thing in terms of like digital fabrications and all this. So how this thing, you guys gonna put it together as the whole ecosystem as a solution from the software point of view?
So construction cloud is like a kind of number of cloud solutions which we have. So it's like a Plan Grade or Beam 360. These are the like normally used used in this construction industry to view, to schedule the work in the virtual world as well as on the construction world. So these are the products like connecting, making as a bridge to in between. So we don't need paper anymore, so paper drawings or whatever. So these solutions will help into that. We have another cloud-based platform which called Forge that will connect this entire software solution to make a kind of applications or automated software solutions. So any partners can come and take that opportunity to take the Forge platform, and they can build their own applications. Yeah.
Okay, that's good. Tino, you have other
Yeah, well, I mean, I was just thinking, Cobot Hedrick has been doing, I mean, technology has improved leaps and bounds over 3 years, and it has markets in Middle East, Europe, and Africa. Will you think sometime, maybe when the pandemic is over, you come over to Asia, this part of the world?
No, we actually also, we have one of our printers in Asia right now. I can't disclose more details of it, but there is one of the printers in Asia already. And yes, I mean, Singapore is definitely extremely interesting for us, and you know, actually made very relevant by the COVID. But we had already, prior to COVID, we had sort of we've seen one of the limitations in our sales. We get, just to give you a picture, we get thousands of requests every year, right? Thousands of requests for information. People see this new wonder thing and they want more information, and maybe 20 or 30% are dreamers, you know, hey, can you come and print me a house in my backyard and things like that. But we take pride in trying to answer each and every single one that comes in. So we have a huge funnel, you can say, of thousands of leads. We then make sure that we send very solid information, a lot of information the first time. That already scales down the amount quite a lot, because people get, you know, they get a price list, they get all kinds of information. And so most of the dreamers are then disappearing, etc. And, you know, more and more we sort of scale in. Eventually, there will be like maybe, I don't know, 50 to 80 companies visiting us per year. And what we've seen is that it's necessary for people still consider this, or organization companies still consider this to be very risky. So they will not buy it before they have been to see us. They've been to see a live printing session. They've been to see the bot building. They've talked to our various experts, etc. So we've been thinking, okay, we have difficulties in getting everybody to Denmark, because Denmark is not the middle of the world, despite what I think, or the center of the world. So, you know, when Mohammed will not come to the mountain, maybe we have to move to the mountain to Mohammed. So we're actually looking at establishing competence centers, as we call them, regional competence centers, where you will have a printed building, you will have a printer, and you will have a local team. And the hub for Asia is actually destined to be Singapore. So we have identified Singapore, Dubai, and Florida as the 3 hubs that we want to have to service respectively Asia, Middle East and Africa for Dubai, and North and South America for Florida. And then from Denmark, we can service Europe. So if anybody is interested in discussing that, I'm all for it.
I'm really looking forward. Well, Vijay, do you have anything to add? I mean, Autodesk has also, I mean, similar strategy of machine learning, you know, 3D simulation design tool. Do you foresee yourself working with Hedrick in the near future?
Yeah, well, why not? Yeah, I'm super interested.
You want to buy a printer, Vijay?
Yeah.
Good.
I'm sure Singapore is like a kind of like a welcome, will be warm welcome you on that. perspective, because we are getting many requests from institutes, yeah, some other regions. So maybe I'll take it in a on the background. We'll talk.
Yeah, you're more than welcome. You have NTU also, Nanjing, that is very, very good and has done a lot of interesting research. And I would say is, together with Swinburne down in Australia, is the leading academic institution in Asia. Super good research, interesting projects that they've done. They have printer technology also. They are working very closely with Eindhoven, which is a leading university in Europe and the world, I would say, for the application of 3D construction printing. And so Eindhoven and NTU has a cooperation agreement, and they're doing very, very well, I would say.
Great.
Yeah.
Okay, well, it's great, guys. Okay, sorry, because I think we running out of time now. It's like 3:07 now. Okay,
You're throwing us out.
All right. Okay. So yeah, I think I need to wrap up. So okay. So hopefully all of you have a a good time session today, right? Thank you, Henrik, for your sharing. Thank you, Vijay, for your sharing as well at BeyondX event. Okay. And for audience members in Zoom and also Facebook, right? Thank you for your time, right? You guys also can check the other schedule today in the agenda, as well as the other session for tomorrow. Okay, so we will doing this BeyondX on a yearly basis. So we will see you guys again perhaps next year in 2021. Okay, either in a digital platform or maybe in a physical platform if the situation is allows. Okay. All right. So I think thank you all. Thank you so much.
Thank you so much.
Thank you, guys.
Thanks.
Thank you.
Bye-bye.